ahead and continue where we left off. We're working on a practice problem, and it looks like this. So and this is continuing on with stoichiometry. When 45.8 grams of K2CO3 react with excess hydrochloric acid, how many grams of KCl is formed? So we've got some extra information in here. We see 45.8 grams of K2CO3. Well, that's one of our reactants here. It says with excess hydrochloric acid. That just means there's so much of it we don't really even have to worry about it. Okay, this is not going to limit our reaction at all. It's going to react and form how many grams of KCl? Okay, so what we have is, we need to balance the equation. Notice if you pause here and go balance the equation, we're going to have a 2 here. 2 K's over on the left, that means we need 2 K's over on the right. Alright, so what have we got in the problem? It says 45.8 grams of K2CO3. And I apologize for the snoring that is going on as well, by the way. This is why I'm not at school today. Alright, so K2CO3 is 45.8 grams, and we're searching for the grams of KCl that's formed. So if you go over to your mole map and you look at grams to grams, okay? So we're once again doing gram to gram conversion. There's my mirroring friend. I lost my mirroring, it fell asleep. Much like the toddler sitting on me. Okay, there we go. We are going from grams, to grams, and remember our last time we did grams to grams, we used these conversions. So we're going to use this same setup. Again, we're going to have molar mass, of A. We're going to have mole ratio, A to B, and we're going to have molar mass of B. So you're essentially going to be using this molar mass, mole ratio, molar mass setup on a lot of stoichiometry problems. Like a little puppy. Okay, so let's go ahead and just set this up. We have 45.8 grams of K2CO3. First thing is that molar mass. So if we go back to our periodic table, we're looking at 2 potassiums, we're looking at a carbon, and 3 oxygens. Take a second, calculate that molar mass out. Maybe pause the video as well. Alright, the molar mass of K2CO3, we want grams to find their way to the bottom so that they cancel out. So I hope you got 138.21 grams of K2CO3. We're going to put 1 mole of K2CO3 on the top. Grams cancels. Our next conversion factor, as shown here, is the mole ratio. So I'm looking at my balanced chemical equation, the mole ratio between K2CO3 and KCl. So moles of K2CO3 are going to go on the bottom. How many? Well, there's nothing written out here, so it must be a 1. So 1 mole of K2CO3 on the bottom. And on the top, I'm going to put my 2 moles of KCl, as shown here, 2 in front of the KCl. So my moles cancels, and I have moles of KCl. My last piece is this molar mass. I need the molar mass of my substance I'm solving for. Well, I'm solving for KCl. It's so loud. The KCl, you're taking the molar mass of that, so you're going to do potassium and a chlorine. And hopefully, if you pause the video, you get 74.55 grams of KCl over 1 mole KCl. So our moles KCl cancels, and we have grams KCl right here. Alright, calculate it out now. Pause the video and make sure that when you calculate, that you try this calculation and that you get the answer that we're going to go through in a second. So you take 45.8 times 2 times 74.55, all divided by 138.0. Alright, so as you calculate things out, make sure you pay attention to significant figures. How many sig figs did you start with? I see 3. Both my molar masses have 4 and 5, so those are definitely not limiting me. I need to end with 3. So I got 49.4. Did you get that? If not, try calculating it again. See if you made a mistake in putting some number in. So that's the amount of KCl that can form. Well, that's great. So essentially, stoichiometry can be used to convert from one unit of one substance to a unit of another substance. And it is all based on using the mole ratio. So I was going to point out a few different scenarios for stoichiometry to be used. The very first one, it's a mole-to-mole conversion. Anytime it's mole-to-mole, you're just using the mole ratio, and that is it. If you're going from mass of A to moles of B, or the other way around, you're using just molar mass and mole ratio, or mole ratio and molar mass. If you're going from mass of A to mass of B, it says molar mass, mole ratio, molar mass. I hope this is a very entertaining video for you. So here's molar mass, mole ratio, molar mass. Poor kid. Oh, baby. Okay. So here's the cool thing about stoichiometry, is it is used by synthetic chemists anytime they're trying to predict how much, or anytime they're trying to say, alright, I'm starting with this amount of material and figure out how much product they can make. Now this is all very theoretical. It's on paper, right? So you've essentially said on paper, if I start with this mass, I should end with this amount of mass of product. Well, side reactions happen. Chemistry doesn't do what you want it to do. You spill things. Reactions don't proceed correctly. And you don't necessarily get what you set out to obtain. Okay? So I want to point this out, that when I calculate the mass of a product using stoichiometry, this is theoretical. On paper calculation, what can I make? Okay. Then there's what actually happens. So we have this calculation called percent yield. You've used the calculation in a different, I guess, scenario when you did the copper loss, copper found log. You had a starting mass of copper and you had an ending mass of copper, and you were comparing the two. Theoretically, you would have ended up with the same amount of copper that you started with. But you didn't necessarily end up with that mass, right? So you had an actual mass divided by that initial mass, or the theoretical mass, times 100, and gave you percent yield. So we're looking at how well did you get through all of the steps of the reaction, right? Well, this is going to apply now to a reaction in which you are taking the actual yield of something that you made and compared it to the theoretical yield, which was calculated by stoichiometry. So the actual yield is what you measure out in the lab, and then the theoretical yield is what you calculate out on paper to be the mass that you will get. So in that previous problem over here, this 49.4 is a theoretical yield. It is a product, and so you are theoretically making this amount of product. The question is, do you actually make that amount of product? Possibly, but possibly not. Okay? So you want to document this equation in your notes. It is on the Quality Core reference sheet, I'm pretty sure. So you've got your measured in lab and then calculated on paper. And this is telling you this is usually a fraction. Typically it comes out less than 100% yield. If you get greater than 100% yield, then something else is in your product. Okay. So here's that previous problem. Theoretically, we should make 49.4 grams. But what if we actually only made 46.3 grams? Well, we would take that 46.3, we divide it by 49.4 times 100. Take a second, calculate it out. Right, so you should have gotten 93.7% yield. Mastery! Right? Yeah, so 93.7% of your product actually did form. But where'd the rest of it go? It's possible that some of the product didn't form, and maybe you still have some K2CO3 in the mix. Okay? Maybe some of it's spilled. I don't know. Maybe some of it is still on your filter paper. Possibly. So depending on, actually it wouldn't be on filter paper because it would be in aqueous conditions. So there's all kinds of ways that you could have lost that mass. Okay? Alright, so that is actually the conclusion of all these notes. I was so close to being done before the little baby had a fit. Stoichiometry takes practice. You just have to plug away at it. Those of you in first and second period, you did not get to read the sections in the textbook. You can always ask your sub to make some more copies of them. There might be some extras from third and fourth period. There's extra resources all over the internet. So if you go into our class website, and we're uploading, it is Chemistry Resource Library. Resource Library. The uploading of the video is taking more efforts. Well, anyway, there should be links that are posted on that Chemistry Resource Library that go through all kinds of stoichiometry practice problems with videos that you can look through in addition to the one that I'm making you. But it is definitely not something that just comes to you by watching me do it for you. You have to do it yourself. You have to practice these extra problems, okay? If you get stuck on anything, send me a picture of what you've written out. All of units need to be, all labels need to be included, okay? Alright, so I see, look at that, all kinds of extra practice in here. Here's the link for stoichiometry. Here's a link for percent yield. Here's another one for percent yield. So